This is gyroscope. Some people they call gyroscope. 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 And this one, the wheel, like a flywheel, heavy wheel, is rotating. And when it is rotating, it will keep the direction as it is. And this is used in spacecrafts and nowadays the scooters, so that they don't fall when it is rotating. It will keep the balance. See this one. Now what I will do is, to rotate it, I will use this string, and this string in this small hole I just insert, and then I wind it. You can just see that. I will show everything like this, and then I will just wind this one so that I can pull this string, and I am just using this one to wind the string around the axle of the wheel. And now this one, the string, I just pull it little bit gradually in the beginning and quickly at the end, so that it will just rotate. See here. See, this one is rotating. And still it is rotating. You see here, this is rotating. I am holding the axle so that it is just freely rotating, and if I break it, I mean slow down, you'll see. It'll just slow down. You see, like that. Now I will again wind the string around this axle, and again, you see here, like this. You can just hold it slowly so that it slips through my fingers, and it will be wound on the axle. And then I will just keep this on my palm. You can just see that. Okay. 1, 2, 3. Now it is rotating. You see here. Like that it will come. I'll again make it. Now this string, are you able to see this?
Yes.
So, and there is a hole. Are you able to see this small hole? This one? No. Here I will just here, you see here?
Yes.
Now this one string has gone into the hole of the axle, and now I will just in the beginning not to slip, afterwards make it little bit tighter. You see, are you able to see this?
Yes.
And the string is getting wound, is it not?
Yeah.
Okay.
Like this.
Yeah?
Okay.
Okay. Like this. You see, this string is wound around the axle. Make it little bit tighter. So that's why I'm just using this one to make it little tight when it is wound. Okay.
Okay.
And then afterwards I just hold it with one hand. You see here?
Yeah.
Are you able to see?
Yeah.
This side is free and this side is wound. Okay. This is a fixed one. This is fixed one. You can hold it here or here, and then you can hold it and keep it on the table or palm. Okay. Once it is kept, it will be standing on the axle without falling. Okay.
Okay.
Now I will just are you able to see this?
Yeah.
Are you able to see?
Yeah.
See this? यहाँ रखना
वहाँ रखना,
और पास करो
हम्म,
okay
हम्म,
are you able to see this?
Yes.
You see it is spinning.
Okay.
Gyroscope. Some people in Europe they say gyroscope, and the wheel is rotating very strongly like that. Okay. Now you see this gyroscope. I just pull this string so that the flywheel like gyroscopic wheel starts rotating, and then afterwards on this palm of my Queen SiRaja I will keep it. Okay. You see, like that. Go a little bit. ऐसा करे. नहीं. See here, it's rotating. नहीं होता. Again I am trying. You see here, I am trying to pull this one, and nothing will happen to you also. And this one I am just pulling it, and because when it becomes loose, it will not be fast in rotation. So when it is fast, it will keep rotating vertically on the axle. So I'll just make it. You see? Okay. Now I will just see this string. I am just trying to wind it. Okay. This end is going into the hole. So I'll just insert this one into this hole, and then you see here, and then first I will just make 2-3 windings, and afterwards like this.
Okay.
Are you able to see this?
Yes.
Okay, good. Now the string is wound on the axle, and this string when I pull, I will leave it on the ground, and then I will keep this gyroscope on my palm. Okay.
Okay.
All right. Now I'm. The speed is not good. Now it is standing. Are you able to see?
Yes.
It is spinning now. You
Yeah.
see? Okay. Now that's okay. Now this one. Are you able to see the? Okay.
Legs. Yeah.
It is rotating high speed, and slowly it will stop. It will stop. When it stops, you can see slowly. I'm just slowly slowing down on the axle. Now slowly stopping. You see here how it is stopping?
Yes.
Because of inertia, the flywheel takes lot of time to stop, and that also it is stopping because of little bit friction at the bearings of the axle. Otherwise it will never stop because of inertia, but because of friction it stops slowly. You see here? 1 minute. When it stops, I will tell you. So this is called gyroscope, and this axle, it will be this one is rotating. When it is rotating, it will keep this direction. In the spacecraft, if it is to rotate in this direction only, if it is to be kept in this direction only to go in the space, it will be kept like this, so that it will create this direction fixed in space. And the rocket, wherever it goes, this has to be kept in the same direction. Okay? Thank you.
Okay, so we've got this little gyro, and this rather large monstrosity, which is also a gyro. Now, I just want to do a quick demonstration on the importance of bearing friction in the gimbals. So let's give this a nudge in the clockwise direction, which is where we would expect precession to go. And while that one's going, let's do the same one for this little guy. And see who stops first. Maybe the little guy needs more steam. Wow. Such a beautiful rotor and gyro, and yet the gimbals are complete crap. That's not to say that this thing is a gem. The tape on the outside is so that I can use a Dremel to spin it up. And I've got a paper clip in here to tighten up the hub in the event of, well, if it tips down like this, I don't want the disc sliding down, so I've got it fairly solidly in place thanks to a paper clip. Try to make sense out of it. I can't. So this guy clearly, for its mass, has a lot less bearing friction to deal with than the much more attractive little guy. First, I'm going to demonstrate precession from weights. I'm going to spin it up with a Dremel because it's easier than spinning it up by hand. Okay, that's fast enough. It's oscillating a bit because of the forces I was putting on it. Now watch what happens when I put a weight on it. Let's try that again. Alright, the weight's dragging on the wheel, but And I got a bit of mutation going. Okay, that's damping out. Now what's happening is the torque is causing the precession. The precession is actually acceleration. There's no angular momentum involved here. In fact, if I pull one weight off, it slows down. And of course I induce an oscillation in it. Can't help that. Let's let it go around one more time. Flywheel is losing energy fairly quickly, unfortunately. Come on, hurry up. People are falling asleep. And now, pop the rest of the weight off. And it stops precessing. Just like magic. Actually, one of the really cool things about a gyroscope is it's a physical manifestation of vector cross products. So there is indeed quite a strong link between math and physics. Okay, that's the end of the demonstration. Well, I can try to press down and you'll notice it wants to go that way. Or I can push and it'll want to go up and down. Basically, the torque I apply will be rotated 90 degrees in the direction the rotor is spinning. Now, if there was more friction in the system, this would dampen out faster. So, just put one hook, no weights. Sufficient to make it precise. I'm losing the energy in the wheel. As you can see, it doesn't take a lot of friction in the system to bring it to a halt. So I'm actually very skeptical that I will be able to demonstrate the rotation of the Earth with this apparatus. Well, that would be damn cool if I could. Okay, enough of that.
Okay, hello friends. Aarwin, Sophie, Aamirah, Aamilah. You see here, this is normal fan, used fan, and this blades, these 3 blades, I have taken this one for our game, and I fixed it on the half of the Eiffel Tower model. You see, when we went to Paris, we took this one, and this one I modified in order for the clay, and this is I just put it old hanger. I just took the wire and then bent, and I attached this one as a marker. Okay, and this is main purpose is when you rotate this one wherever, and here there are numbers. You see here, what are the numbers? Can you read?
9, 2, 6.
What is this number?
2, 6, 9.
What is this letter?
H.
Here I have written Sophie, and this
Sophie.
is Aamirah.
Aamira.
Are you able to see?
Yes.
Okay. Next, in this blade of the fan, what is this letter? The
5.
number?
5, 3, 7. Yes.
And what is the name?
Aamilah.
So, and on this blade, what is the name written here?
Aarwin.
Aarwin. And what is the number here?
4, 8, 10. O, L.
So, these are the thing. Actually, why I have written is, can you read these letters?
Yes. H, L, shawl.
No. Sorry, you have made a mistake. S.
S, H, O, L.
It has not come.
Okay.
You have to talk when it comes at the bottom. What is this one? Okay, tell me.
Yes.
What is this letter?
Yes. H, O, L.
S-H-O-L. S-H-O-L. This is S-H-O-L. Shawl. Shawl means SiRaja Home Organization for Lifelong Laboratory. Okay. And this one, if I just rotate, and suppose you just tell that you are betting number 3. If it comes here, you are winning. Otherwise, you have to, you are a loser, and you can just keep some rules, like if you are loser, you have to dance. If you are loser, you have to just say some rhyme or poem, or if it is like that, you can just keep some small chits with numbers, and that chit, whatever it is written, you have to do that.
Okay.
Which number you want to do it now? What number you want to bet? Any number, you just choose.
2.
2. Let me just rotate and then see where it stops. See, it is rotating. You see here?
Yeah.
Are you able to see?
Yes.
Okay. When that 2 comes here, you are winner. Now, sorry. Now you have to dance. Can you just make some dance here? Or give a poem? Okay. Like that you have to do it. Suppose I am a loser, then I have to say, okay, I am dancing. Or if that chit says, sing a song or poem, then twinkle, twinkle, little star, how I wonder what you are. Like that, anything, whatever. Next, last time we will see. Which number do you want to do?
8.
8. See, she said 8, and I will rotate. If that 8 comes here, she is the winner, and whatever she says, I have to perform. Okay? 8 you have to do. See, this is rotating. Are you able to see in all directions?
Yes.
Okay. If it comes 8, okay, 8 is nearby. So, because it's nearby, you are winner.
Okay.
Okay? You tell me what you have to, I have to do, because I am loser.
Okay.
Anything. Quickly.
A, B, C, D.
A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. In India, we used to say Z, but many people, they started American way, Z means Z. Okay, thank you. This is the fan game. Okay, bye. Hello friends, now this is water filter, and we pour the water here, and then close this lid like this, and afterwards if you want to, if the water level goes down, and again we fill up like this. This is the lid, this copper bottle, and this is Queen SiRaja's copper bottle on bedside. And this one, you see here the water, are you able to see? This I am filling the water, and then I will fill up this also with water. Okay. Now I will see how the water is filled up, filling in the glass, this copper bottle. Okay, the copper bottle is brought from Aurangabad. Okay, and this one, you see here, this water. Okay, like that. Again, you see water. I am just putting it, pouring it into the water filter, and again I will just see the water is, I open, different sounds are coming, you see. According to sound you can say it is filled up or not. So this is filled up. I just close it with the lid, okay, and I just keep this one here. This is Nanamma's water bottle, and this is my water bottle, and this is also copper bottle, and this is taken from Guwahati, that Shillong area, when we visited India 2 years ago. Now this, not 2 years, 3 years ago. Now this one again I just put it. You see here, it starts sounding differently according to the high depth. I just take it now. Okay. Now the sound indicates that it is full. I will put it again, and I will let you listen to the sound here. You see here, I am opening the valve. Getting filled up. The water is mixed with the air, oxygen. Like this. This is water is filled up. Thank you very much for watching it. Okay, you also do some experiment at home. Thank you.
Friends, today we will make a wonderful gyroscope with help of some CDs, toy motor and the battery. When I switch on this motor, see what's happened. This is the most amazing gyroscope.
As a heavy disc spins at a fast speed, it prevents the big CD from falling. The CD gyroscope stands erect and slowly spins on its point of contact. You will need 5-volt CDs, glue, scissors, a 9-volt battery, switch, a 9-volt toy motor, etc. First mark a small circle on 4 old CDs, and then cut them with the scissors. Then glue all these 4 small CDs together with glue to make a thick, heavy disc. This disc will act like a flywheel. Stick 2 small pieces of CD on both sides to cover the big hole in the flywheel center. Now drill a small hole in the center of the flywheel. Tight fit a piece of small ball pen refill in this hole. Now this is the flywheel. Attach a 9-volt toy motor in series to a 9-volt battery and an on-off switch. On switching on, the motor will spin. You can perhaps only hear the sound but not see the spinning motor shaft. Stick a rubber frame to an old CD. The frame will house the 9-volt battery. Fix the motor in the center of the CD with strong glue. Then place the battery in its housing. Tie the switch. Then on the other side, tight fit the flywheel on the motor shaft. Now the flywheel is attached to the CD. Finally, on switching the motor, the flywheel will spin very fast. Now stand the CD on a table. The CD will not fall down because of the spinning flywheel. Why does the CD stand and not fall? The spinning flywheel acts like a gyroscope. Its axis of rotation is free to assume any orientation by itself. Even if you tilt the CD, it returns to its original position because of conservation of angular momentum. That is why gyroscopes are used for maintaining orientation.